This talk is an overview of artificial intelligence. In my data science talk, I explained that data science was an amalgam of many different fields. But I disagreed with some commentators in that I believe the term data science is very useful precisely because it explains this amalgam in a concise way. Artificial intelligence, which is part of data science, is also an amalgam of many different fields. It's just an older amalgam. If you're a practitioner in data science, it's important to have a sense of what artificial intelligence is and what the term means. I'll say more in a bit about what some of those fields are that go into artificial intelligence. But first, our general philosophy is that we shouldn't try to duplicate some of the excellent free resources that are already out there for you. So I'm going to recommend you check out the many detailed articles on Wikipedia on artificial intelligence. Khan Academy has some excellent free videos on artificial intelligence. The standard textbook in the field is Russell and Norwig, AI, A Modern Approach. It's currently in 2017 out, has 4 editions. You can get any edition, they're all excellent. They're not free, but you can find a table of contents or some other, or previews of the book available for your view, and either free or at no charge. When you talk about artificial intelligence, there's always the philosophical. Can machines be made to think? Should machines be made to think? What does artificial intelligence mean? And there are different variations on this. There's strong artificial intelligence where the machine is actually intelligent. This doesn't exist, at least in 2017, at least in the general sense. And there's weak artificial intelligence where the machine exhibits some intelligence or some intelligent-like behavior, or is perhaps a savant in a specific, very specific form of intelligence. You can quickly get a sense that artificial intelligence is among the most economically important technologies of our time, up there with anything else you can think, at least according to some analyst reports. There are analyst reports estimating it will create hundreds of billions of dollars in economic value over the next few decades. It is the steam engine or the steam railroad of our time. And like the 19th century steam railroads or atomic technology of the 20th century, it is a force of disruption, of peril, and potentially of great fear. It's the most exciting technology of our age, but also the most controversial and the most potentially disruptive. Artificial intelligence draws on all fields, from statistics, economics, linguistics, philosophy, neuropsychology, psychology, neuroscience, evolutionary biology, and so forth. Certainly logic, formal logic, mathematics, theoretical computer science, engineering, all go into this mix that we call artificial intelligence. It is an active topic of science fiction writers, of Cassandras, of those giddy with anticipation about the glorious future of mankind that will be heralded by this new steam railroad or this new space technology or this new latest technology of this age. And rather than the doom of accidentally contacting aliens with some new spaceship or the great economic prosperity that the new spaceships or the new atomic age will create, today you hear about artificial intelligence that's captured media attention. And as with all of these previous technologies, there is some truth to all of this, as well as plenty of hype. We live in dangerous and exciting times. We've already talked about the philosophical foundations. Can a machine really think? What is strong AI? What is weak AI? What is the past and future? Are we going in the right direction? But we'll be coming back to those points again and again later in this talk, and there's something that you should keep in mind as we give this overview of the different components of AI. AI is very closely tied to the power of computing, Moore's law, which is going exponentially. And one way to organize AI is to think about the history of AI. So you have, in the early days, the symbolic or the good old-fashioned AI, which made a lot of sense when computers were much slower, but is still very important today. It's the Pareto's law of efficiency. It's one of the first things that you try. 80% of your results come from 20% of your effort. There are statistical and mathematical techniques. These have been around since the earliest days, but today we have this era of big data where we can truly process huge data sets and use them to guide decision making. Somewhere in between, we have hidden Markov models, support vector machines, clustering techniques, database systems. As computer power has advanced, these have become more practical and more powerful. And then at the most expensive side, we have neural networks, deep learning, and composite techniques. Neural networks have been around for decades, but have really only become useful perhaps in the last 20 or 30 years as computers have grown exponentially in their power. Another way to organize artificial intelligence is to talk about the problems that we're attempting to solve with AI. Intelligent agents, which have come a long way. Years ago, we just tried to simulate some things like maybe drivers responding on a road, responding to traffic. Today, you've got Siri and customer service chatbots, so we've come a long way. There's problem solving. This is a huge area that overlaps with other disciplines. There's optimization, genetic algorithms, constraints, job scheduling, backtracking paths. There's adversarial search, min-max optimization that's used in chess playing algorithms. There are knowledge-based agents, proof systems, do your advanced math homework for you. Model checking, is an algorithm correct? Agents based on propositional logic. If a computer can do logic as well as the philosopher Aristotle, does that make it sentient? I compute, therefore I am, to paraphrase the great medieval philosopher and mathematician Descartes, who invented the Cartesian coordinate system. There are all kinds of different types of logic. You've got entire artificial intelligence languages built around logic. Prolog would be an example. You have planning in the real world and acting in the real world. You have knowledge representation and learning. There's some really exciting stuff that can be done when you get into probabilistic reasoning and statistical inference, Bayesian inference, which I did a talk on. You've got decision trees, support vector machines, neural networks, theory of learning in there, representation of knowledge, probabilistic methods, reinforcement learning, potentially deep learning in there. You have perception. This is image processing and representing the world in 3D internally. And of course, robotics, controlling a robot. And last but not least, natural language processing, where instead of loading huge amounts of data into a database, you can simply have your AI system read through hundreds of research papers and understand it to some extent, almost like a human can. So we started off on a philosophical question: can machines be made to think? And we ask, should machines be made to think? But all of these problems and AI solutions that I've gone through are a spiral. Intelligence, artificial intelligence, is heavily tied to Moore's law and the power of computing, and that power is growing exponentially with time. So tying all of these things together are these philosophical questions: the exponential growth of computer power due to Moore's law, is this futurist concept of the superintelligence. There are some great best-selling books out there on this topic, as well as some free blog articles. So if you're interested in the philosophical, ethical questions, the science fiction possibilities, or just want to know and understand more around the hype that is AI that's playing out in the media in 2017, Google superintelligence. And that's the end of this talk. Thank you so much for your time.